visual work. Very briefly, we can look here. What I'm reporting now, it's the effort of about 200 people. 200 and more observers in IMO contribute to this program. And so this talk is also kind of feedback to those people submitting their data regularly, which allows us to have, at least for most of the showers, a comprehensive view on the activity. In the first moment, if you see this graph with the observing efforts from the very beginning to now, it seems it's going down. Yeah, if you go, the last bar you can forget because that's 24 and it's not yet filled up. So we are still working on that. So the level probably will raise a bit. But other than that, we have about 11,000 hours per year contributed, and that's slightly going down. The time is over here. But the number of observers, you see, just especially in 23, there was some activity increase on the observer side. And also the rest is more or less, I would say, over the last 5 years at least, more or less constant. It always depends a bit on the moon phases for the major showers, no surprise. In 23, I don't want to go through all, then I could talk about 2 hours or 3. You see that there are these moon gaps where people don't go out for good reasons. And you see also that the major showers have been mostly covered, except the quadrant heats, which were close after a full moon. And I will give you a few numbers now. Actually, I will not show all the numbers. That's boring, and you can read it in the paper, which is giving all the details. And also you will see, I just refer to the graphs which are produced from our IMO website. And yeah, for the publication, you will see some more details about that. It's in progress. So I start with the Lyrids, a shower which is often awaited because it's the long break after the quadrant heats, 3 months with no activity, which is really interesting to go out. And you see, first, we have a good coverage for most of the period. And also interesting, we look just briefly at the maximum periods. So I don't want to deal with all the details far away from the core region. It's not a large number, 513 shower meteors. So that's not something where you can go into details. And the maximum night itself, it's more or less a handful data points. But interestingly, it's almost it's very obvious that this is the highest value we can find. And I would even say it's too good because the handbook gives the average ZHR long-term 18. What we find here is 18 plus minus 3. And the position is 32.32 degrees. And we find it exactly at this position. That's the expected and the observed. So the observers have well studied the handbook and then have found the result. I mean, it's surprising in the sense that we have about 4 hours for each location that you can see the shower with the radiant sufficiently high above the horizon and the morning twilight coming. And so, so you cannot expect much more. So the Lyrids is a good example. The Perseids, that's the most interesting showers for most observers. From these 220 observers contributing each year, I would say it's about 190 just concentrating on the Perseids. So that's another number. It's about 16,000 meteors which are in the sample, and we can be, at least for the maximum period, we can be more strict with the requirements. So we put each bin only with 250 Perseid meteors each. For the Lyrids, it was less than 50. So you see the difference. And also the maximum is lasting for a longer time than just the Lyrids, which is just a few hours. Also here you see the gap in before the Perseid maximum, full moon, and then the general shape of the graph, okay, no surprise. And now we look into some details, because in 23 there were, apart from the nodal maximum at 140 plus minus 0.1 or so, which is also in this area here, two more structures. There was this very old dust drill. When Jeremy sent me the data for the shower calendar, he pointed out it's unsure what is to be expected. Just give it a chance and look. And that's what we find. It's not really convincing, I would say, from my point of view. There is something at this, not exactly at the same time. It's about 2 hours earlier, and it's not very prominent. So it's in the range of the error bars. So be careful when interpreting such things. That requires more investigation, starting with the population index to check whether there is some different population, and then only going to back to the density or the ZHR here. But noteworthy at least. And we can also look, Zoko has shown the ability of the flux viewer, and I looked here, and that's the same period, 2315, which we have here. It's just nothing. And also at 2 o'clock, which is the predicted time, also nothing. So it's more or less continuous activity, which we see here on both data sets. So as I said, it's worth to check for details, but from the preliminary data which we have here, it's more or less open. And then there was a filament announced, which was earlier on the 13th of August, 3 UT already. And we find this funny structure here. Again, you might suppose there's something, but again, you have to look for details. And again the comparison. Yeah, there's also one thing you value. So I think there's a lot of work still to be done. But again, there's enough data available, and it's worth to check all the details. That's work in progress. And we want also, we had discussions also with the EMO Council, we want to increase the number of papers in WGN giving the feedback about these shower occurrences, which were produced more regularly in the past. And we will repeat or come back to this also to give perhaps more stimulation for own contributions. So that was the Perseids. Briefly look at the Orionids. It's a broad maximum. It's not a sharp peak or something. And we find there was something higher on the 21st of October, more or less fitting this maximum. So I think it's not interesting to go into details here, except there's something at 209 degrees. So it's about 1.5 days later. Again, such thing. And yeah, the number is also not that large. Only 22 observers contributed to that. Yeah, again, interesting to check it, because also here, you see, Joko, I like this comparison, because it's always important to have different independent data sets. If you look for something just from one sample, it's fine. But if you have confirmation by a completely independent data set, it's more helpful and gives you some more idea about the reliability of this feature which you have seen there. Finally, not finally, the Leonids. Here I wouldn't go into details because we have no data for this predicted maximum which was before the nodal passage, and the nodal passage is more or less characterized by this relatively smooth thing. So, and also the ZHR is of the order of 12, so we are far away from the parent comet, and so there's nothing more to be expected. Bit more interesting, perhaps the Geminids. Again, the general activity curve very nicely. And something obviously changes in the shower. We had a number of years in the 90s and the 2000 years when there was this broad peak or plateau-like structure with relatively constant level. Then we had a number of years until, I would say, 2021 with some higher rates, where the rates also increased to a level of 150. And now it seems to change again. So the level is rather than 150, it's more 120, something like that. Still an impressive shower, the most impressive one of the year, but not 150 anymore. And also perhaps shorter. That's something which also requires further observations and also investigation. Yeah, that's the single highest value. 19 UT was the predicted position at 262.2, which is the average over many years. And shortly behind that, we have this single value, it's 130 something, but lower than 150 definitely. So, conclusion fun. We have a sufficient amount of data for most of the major showers. That's a good sign, and also the observers obviously were active and concentrated on these periods, which helped us to collect this data sample. It's enough material in the most cases to look for details like these weak trails or the filaments, although still a lot of work is necessary. And yeah, as I said, always combine different data sets. Now something we have always in the shower calendar, these minor events. And to make the story short, there was nothing. Interestingly, most of these possible events were close to full moon, so it was the chance very low anyway. Okay, so now some general remarks. Advertisement for visual observations. Why still doing this today? First, it's a continuation of series which we have, in some cases, back to the beginning of the 20th century, and single events even later, back, even further back. So that's something which should be continued, also for cross-calibration to continue this. And something I would say it's the personal experience. I'm working in an astrophysical institute for decades now, and I often ask students, do you know the object which you see, which you work on? Do you know in the sky where it is, how it looks like? No, I just have the data, have some procedures, and that's it. That's a pity, because if you don't have a good relation in a certain sense to the subject you are dealing with, yeah, it's a pity. And the other thing is, where else do you have physics in action in such a short time scale? How does fragmentation look like? I mean, you can see the videos, of course, but have you seen it yourself? How the object disappears and disintegrates? Sound, you can hear it, some records are there, but I remember a fireball which was there, and 6 minutes later I was really shocked by the sound which suddenly arrived. If you don't experience that, you don't know. You don't wait for 6 minutes, because then the fireball is forgotten. And also you can see things like the meteor, the stream evolution, zenith attraction, or stuff which is simple and sounds so easy, but you can experience it. So go out and look for it. And that's the conclusion for it. Continue.
So thank you, Jürgen, for keeping the time almost to the second. And also thank you as a visual observer, because of course we observe for fun, but then putting all the numbers in the form is not for fun. I mean, we do it for the analysis and for the science. So thank you for the review of the year. I see no questions online, so then I go to the room to see we have time for a couple of questions. Yes, Chris?
Can we go back to page 15 or so with the Geminids? Yeah, that one. There was a discussion on the radio section about the secondary maximum before that. Yeah, and that seems to be real. And it's unexpected for the Geminids, which are very stable stream with a nice profile. Our friend Hiroshi Ogawa studied that. He was almost wrong in assuming that it was from comet Virtanen, because we don't have information about the radiant. So this is something that we can in the future also add that data set to check that one.
Okay, good idea.
Okay, we still have a few seconds for a last brief question. No other. Okay, sorry, I was checking in the chat and I missed Galina raising the hand. So please, Galina, if you can go ahead.
Thank you. Jürgen, I see that rate for Geminids was about 138. So it is below our level lane of regression line. So it is reduction in kind of activity, yes?
Yes, that's true.
I see. I just checked our old publication. Probably it is low level. No, I don't remember. Okay,
I mean, it's difficult to say at the moment whether this is a trend. It's just 1 year, so we have to follow this.
I see that there are a kind of rhythm in this up, down, and in the middle it is increasing, something like that. Okay, thank you.
Okay, thank you, and thank you again, the speaker. Thank you, Jürgen.